Good morning. We're going to talk about R3, graph of proportional relationship. So the definition of a proportional relationship or a proportional function is going to be y equals kx. So when we talk about y equals kx, we know that k is a constant in proportionality. Now let's talk about the graphs of a proportional relationship. We need to know that the graph of a proportional relationship is a line that passes through the origin. The origin is the center of the graph, and a graph has two ordered pairs. So let's go ahead and create the graph on the left-hand side in our notes. Okay, so this is an x and a y. I'm gonna go ahead and label it. It's really generic. I don't know why, but my lines aren't coming out straight. Okay, so I have an x and y plane on the right-hand side, and I'm going to graph y equals 4x. I know that I need two ordered pairs to make a line, and one of them is going to be the origin. When we talk about the origin, we're saying that we have 0, 0. So let's see how this works out. If I say that x equals 0, I'm going to substitute the x back into the original equation. Y equals 4 times 0. So y equals 0. So that means that 0, 0 is a point on the graph. I need one more point. I like to use just like the number 1. So I'm going to assume that x equals 1. And so where x equals 1, I'm going to substitute that back into the original equation. Y equals 4 times 1. So y equals 4. So my ordered pair, my first one was 0, 0. My second ordered pair is going to be 1, 4. So I start at the 1 and I go up 4 units. So I go 1, 2, 3, 4. That's going to be my second ordered pair. Because remember, all I did was go to the right one and count up 4. And now I'm going to connect my two dots to make a line. And there we go. You have a proportional line. It's a little messy, but it'll be easier on the graph. So right here, it says graph this function. So first one is 0, 0. Got to be careful. And the next one's going to be 1, 4. So 0, 0. And then I go up 1, 4. Submit. There you go. All right. So for the next one, I have y equals negative 4x. I know I have to have the origin, so x equals 0. So substitute. This operation is multiplication. So y equals negative 4 times 0. Y equals 0. So my ordered pair is 0, 0. I know I have one dot there. And then I'm going to choose, again, x equals 1. So y equals negative 4 times 1. Y equals negative 4. So my ordered pair is 1, negative 4. So that means I'm going to go to the origin, go to the left, negative 1, and then go up 4, and then submit. We're going to graph this function, y equals 1/2 x. We want to get rid of the 1/2. So first thing we need to graph is the origin. So we substitute x equals 0. So y equals 1/2 times 0. Y equals 0. So remember, this is a proportional function and it always goes through the origin. Okay, so since we don't have any fractions on this graph, we're going to need to make this 1/2 a whole number. So I like to multiply by a multiple of 2. So the reason why we're going to multiply by a multiple of 2 is that our solution will be a whole number. And here's how we do that. Also, when you multiply fractions, you multiply going across. So y equals 1/2 x, and I'm going to choose x equals 2 as my multiple of 2. Because remember, if you count by 2s, it's 2, 4, 6, 8. Whenever you multiply by a multiple, you're going to get a whole number. So y equals 1/2 times 2. But remember, it's 2 over 1 because every whole number has a 1 underneath it. And then when you multiply fractions, you're going to multiply going across. So let's see what that looks like. So it's a 1 times 2 is going to give me 2. And then the divide button or the divide symbol. And then 2 times 1 is going to give me 2. So 2 divided by 2, y equals 1. So our ordered pair, we said that x was 2 and y was 1. Our ordered pair is going to be 2, 1. So then on our graph, it's 2 up 1. And then we submit, and we got it right. Graph this function, y equals negative 9/4 x. I know for sure that I'm going to use my origin. I don't need to show the work for that, so that's just 0, 0. And then because I have a fraction, I want to do a multiple of the denominator. So I'm going to choose a multiple of 4. So when we talk about multiples of 4, we're going to go like 4, 8, 12, 16. You could pick any of those numbers. I like to just choose the smallest number. So in this case, we're going to say that x equals 4. So let's put this all together. So where x equals 4 and our function is y equals negative 9/4 x, we're going to substitute that 4 where the x is. So y equals negative 9/4 times 4. And then it has an imaginary 1 in the denominator because it's a whole number. So when you multiply going across. Alrighty, so then we say negative 9 times 4 is 36, or negative 36, divided by 4 times 1, which is 4. All right, so 4 goes into negative 36. When I divide, I get negative 9. So here's our ordered pair. We said that x equals 4 and y equals negative 9. So our ordered pairs are 0, 0, which we already have, and then negative 9. Excuse me. 4, negative 9. So let's see that. I have 0, 0, 4 to negative 9 is right there. Let me submit. So graph this function y equals 1/5 x. We need to look at the scale of the x and the y. It's counting by tens this time. So even though you have we know we're going to go through the origin, when we pick the multiples of 5, because remember you're picking the multiples of the denominator, we're going to have to pick, we're going to skip the 5s, but we're going to go by tens. So multiples of 5, in this case, it would be 10, 20, 30, 40, 50, 60, 70, 80. And the reason why that is because if you look at the scale x on x and the y, they're still by tens. So in this case, I would just say that x is 50. So where x equals 50, we're going to say that y equals 1/5 x. Y equals 1/5 times 50. So y equals, and that's 50 over 1. So it's numerator times numerator, denominator times the denominator. 1 times 50 is 50. And then 1 times 5 is 5. So 50 divided by 5, y equals 10. So we have y equals 50. I'm sorry, x equals 50, y equals 10. So your ordered pairs are 0, 0, and 50, 10. So let's see what that looks like. So 50, go up to 10, and submit. There you go. Okay, graph this function, y equals 5/4 x. I know for sure I'm going to have the origin of 0, 0. Let's go ahead and plot that. And then because of the scale, I still want to do the multiple of 4, but I have to think about a larger scale. So from here, I would say 400, 800, and then so on. So let's just say that x is going to equal 400. So where x equals 400, y equals 5/4 times x. Y equals 5/4 times 400. And then when you multiply fractions, you multiply going across. So 5 times 400, and then 1 times 4. Oops. So then I get 2,000 divided by 4. So y equals 500. So x was 400, y was 500. So I have the ordered pair 0, 0, and then 400, 500. Okay, so I have 400, and then I go up to 500. Let me submit. I got it correct. All right, see you in class.